Here is what you'll learn in this lesson and what you'll be able to do after this lesson. You'll be able to define and correctly use the 6 main inequality symbols, which are these ones right here. You'll be able to represent a range of numbers using a mathematical inequality. You'll be able to illustrate an inequality on a number line using the correct circles, a hollow circle or a full circle. And you'll be able to order numbers and measurements by magnitude. Let us first take a look at the symbols of comparison. These symbols tell us how two numbers or expressions relate to each other in value or magnitude. There are 6 symbols of comparison. The first one being this thing right here, which means is equal to. The next symbol we have is this, which is not equal to. And then we have this sign right here, which means is greater than. Then we have this symbol right here, which means is greater than or equal to. And then we have this symbol right here, which is less than. Then finally we have this symbol right here, which means is less than or equal to. So as you can see, this sign right here and this sign right here is a combination of this and this respectively with the equal sign. An example for each of them: 7 is equal to 7, 5 is not equal to 7, 7 is greater than 5, 7 is also greater or equal to 5, and also we have that 5 is greater or equal to 5. Then we have 5 is less than 7. We also have that 5 is lesser or equal to 7. And we also have that 7 is lesser or equal to 7. These are some of the examples of these symbols being used in practice. These inequalities that we just talked about, they can be represented on a number line. And the type of circle will show whether the boundary number is included or not. What this means is that if we say something is less than 7, then is 7 included there or not? So obviously it depends. If it's less than 7, then 7 is not included. If it's less than or equal to 7, then 7 is included as well, because it can be equal to, based on the inequality sign that we used. Whenever we have either of these two symbols, which is the less than or the greater than, without the equal to, the circle type will be a hollow circle, which is this thing right here. And what this means is the number itself is not included, and it is known as a strict inequality. On the other hand, if we have either of these two symbols, this is a solid circle, and this means that the number itself is included. and it is known as a inclusive inequality. The way I like to think about it is in form of a donut, right? That hole in the middle tells you that you have no donut at that point. While if you have a solid donut without the hole, then you have a donut at that point. Therefore, that number is included if it is solid, and the number is not included if it is hollow. Now let's look at examples for each of these being used in practice. For the first one, we're going to look at x is less than 7. And on a number line, which looks like this, where at 7, you're going to have a hollow circle because that 7 is not included. And because x is everything less than 7, you're going to illustrate that towards the left of 7. Because all the numbers towards the left of 7 are all less than 7. So this line represents the values of your x. That's how this x less than 7 is shown on a number line. Let's look at the next one. We're going to look at an example of x is greater or equal to 5. On a number line, we will have our number 5. And at 5, we're going to have a solid circle because that 5 is included. And x is everything that is greater than that number as well. So your line will be towards the right, and it goes on forever because there is no restriction at the top, so it can go up to infinity. That's why we draw an arrow here. And this will be the representation of x is greater or equal to 5 on a number line, where that line represents what the values of x can be. We can combine the two and we get something like this. X is less than 7 and x is greater or equal to 5 at the same time. And this on a number line, we will start off by drawing our number line. We have two values that we are interested in, 5 and 7. We're going to have a solid circle at 5 because 5 is included. And we're going to have a hollow circle at 7 because 7 is not included. And the values of x is everywhere in between those two circles. So we'll draw a line between them. And this line represents the values of x. Obviously that x will be including the 5 because there's a solid circle there. And that x will not be including the 7 because there's a hollow circle there. Finally, we will be talking about ordering magnitudes. And what we are doing in this part is we are ordering in terms of size different numbers or measurements that are represented in a mixed way. So for example, some can be fractions, some can be decimals, some can be mixed numbers, and for measurements, some can be in centimeters, some can be in meters, some can be in kilometers, and we're gonna compare them and order them in terms of size. The first part talks about ordering numbers, where you may be given numbers in fraction, in decimals, percentages, and so on. The idea in this section is to convert them into a common form. The easiest one to work with is decimals. So the standard way of doing these type of questions is to convert all the fractions and all the percentages into decimals. If you do not know how to do that, click on the info card on the top right. Let us look at an example of this. Order from smallest to largest the following numbers: 1/2, 0.6, and 40%. We want to convert all of these into decimals. And we know that 1/2 is just 0.5. 0.6 will remain 0.6. And 40% is 0.4. Ordering it from smallest to largest, we start off with 0.4. And then we go on to 0.5. And then we go on to 0.6. But remember, that's not the answer because that's not the values that they gave you. They gave you the values in this format. So we're going to write our final answer in this format as well. 0.4 was represented by 40%. 0.5 was represented by 1/2. And 0.6 was represented by 0.6. So that is the numbers ordered from smallest to largest. The next part is when you're given measurements. So in centimeters, in meters, in kilometers, and so on. And the idea of this is similar to the previous one, where you want to change all of them into a common form. Usually we change it to the smallest measurement that we are given. So if in an example, we are given 30 centimeters, 0.5 meters, and 0.0005 kilometers, then we are going to convert all of them into centimeters because that's the smallest unit of measurement from centimeters, meters, and kilometers. So 30 centimeter will remain 30 centimeters. 0.5 meters will become 50 centimeters. And 0.0005 kilometers will become 50 centimeters as well. Therefore, when you're ordering from smallest to largest, we will have 30 centimeter first. Then we will have 50 centimeters. Then we'll have the other 50 centimeters. Obviously, this can be interchanged in this special case where they are equal to each other. And we will put them in the form that they were asked in the first place. So 30 centimeter was given as 30 centimeters. This 50 centimeter was given as 0.5 meters. And this 50 centimeters was given as 0.0005 kilometers. And that's going to be you ordering them from smallest to largest when they're given in form of a measurement.